Hey, Snackers, this is Kareem Iskander.
Hey everyone, Matt DiNapoli here.
Welcome to episode 175, Snack Minute.
Back by popular demand, we're going to have tech advocates answer the most searched tech questions with Quinn Snyder, our most prolific guest. I had to read it because I kept getting it wrong. But Quinn, welcome back for our new snackers. If you wouldn't mind introducing yourself, and then we'll jump right into it.
I'm sure they've all seen me by now, but I'm Quinn. I work in learning and certs as a technical advocate with Kareem.
And we have Emma Pierce today, who's going to be asking us the questions, and then we'll provide the best answers we can. I mean, Kareem and Quinn will be giving you better answers, and then I'll pitch in my 2 cents for what it's worth.
Let's get rolling. Emma, feed us.
So these questions, again, like last time, were sourced by the Cisco community, Reddit, the internet, kind of what the IT community is asking presently. So the first question is, thinking about 2025, if you were to start getting into tech from the ground, how would you start a career in IT or in tech?
That's a really good question.
In 30 seconds or less.
We have to think about it. I mean, I think it depends on, again, it goes back to, it depends on your interest. I think it's important that you do something that you like, so it doesn't feel like it's a chore, like hanging out with Matt and Quinn here. It's really important to do that. I think if we are starting today in 2025, the basic skills of programmability, automation, dabble into knowing a programming code, a programming language really, really well, that's going to help you in all of that, including, since we've all been talking about it forever, just get to know AI and know what it is, how to use it, and how to incorporate it into your day-to-day thing. That those are the basic skills that I would be getting started, just knowing what's going on in the market today. What about you guys?
I think I'll jump in on here. I would tend to agree with you, Kareem. I would say for those that have the means and they feel comfortable with the level of math that goes along with it, I think computer science degrees are always worth pursuing. I will say those can be extremely challenging, especially on the math side of it, if I'm being fair and honest. For those that are looking for more applied computing type things, I think code camps in conjunction with maybe an information systems or an IT degree are probably really good as well. I think the other side of it is in the infrastructure portion, that's not always something that's academically pursued. I think it's worth looking into things like CCNAs and CCNPs and kind of looking at those levels of certification. I don't think that there are any BSs in network engineering. I could be wrong. But those things are definitely helpful in the real world. So the combination, I think for someone that's just getting started, coding camp and a CCNA would probably be the two best things, very directed, that they could get into, because that would hit the programmability and it would hit the network engineering space.
I'll agree with you, Matt, and I'll keep mine short. I think the only other thing to add to that would be some kind of like Linux proficiency, whether it's like Linux Plus or you go through like some of the stuff through Netacad.
Oh, yeah.
I know that the AI is the new hotness and everyone's talking about it, but all those systems run on Linux, and there's still stuff that we touch every day on the internet that is still running on 20 and 30-year-old Unix-based systems. So having some familiarity with Linux, Unix, the shells, how to operate, how to move around them, I think is very valuable because, to your point, the network, the programmability, and the system side, you can kind of pick your own path from there, whatever interests you.
Yeah, I think that that's good advice. I think for the AI portion, I don't think necessarily understanding the full infrastructure deployments and how things work under the hood is an absolute necessity. I think kind of understanding the more useful productivity side of it, prompt engineering and things like that, I think would be helpful. If you want to get paid, though, we're running out of COBOL engineers. And so you can go back, Quinn said 20, 30 years, you want to go back 50 years and save some systems that are still running airline scheduling and hospital billing. Surprisingly, there's a lot of those are still running on mainframe systems where COBOL is still hugely used.
Also, there's an aspect that we're leaving out too here. If none of that sounds really, interesting to you, security.
Oh yeah, that's
Threats are everywhere, especially in today's world. And so having a really, having the skills in cybersecurity and ethical hacking, those are really, really important skills that you should probably look into. And I think anybody and everybody should have whatever you're doing plus security, whatever you're doing and cybersecurity. Like that's important to understand. If you want to focus on it, go deeper.
It's at every layer of the stack, and
Yeah.
it's incredibly important at every layer of the stack. That's a really good point, Kareem. I hadn't thought about that. I think those were all really good answers.
Yeah. High five.
All right, Emma, let's move on to the next one.
So what skills do I need to combine AI with networking?
Everything we just talked about.
Pretty much, actually.
So one of the ways I've been thinking about it is AI for me, and I think I'd lose my mind if there's a different way to think about it, but I'm thinking of as another abstraction layer. And so we've been treating APIs as an abstraction layer for getting down to the network controllers or the network devices, or I should say the infrastructure controllers and the infrastructure devices. But AI adds a layer of abstraction on top of that. So we don't necessarily, as users, potentially have to interact with the APIs. There's some layer of implementation that has to occur for that abstraction to work well. And if you want a little more background on that, check out our previous episode or a couple weeks ago where Hank talked about his implementation of CML into the CCNA mentor bot. Like the key part to that is understanding how logic works and how data structures work. Again, we don't need to know how large language models are tuned. We don't need to understand how vector databases work necessarily. But it is helpful to understand the things that are being abstracted so we can build on top of them. We don't need to know all of it. I mean, because of the abstraction layer is giving us the opportunity to make things easier. But it doesn't hurt to know CCNA, know some of the logic that goes along with coding. To Kareem's point, maybe really understanding a programming language really well, because those skills are pervasive across all of those. And then we can add that layer of AI on top and really take advantage of it appropriately.
And I think there's also one thing to add to that is what we've been talking about for years and years is understanding what APIs are and how they work.
Mhm.
So the basis of all of this is a bunch of APIs going back and forth, data getting sent back, you doing something with the data, sending that data payload to another service via API. So like if you don't know how API works and how to build that out as part of your code or how to use requests if you're building in Python, like these are skills that these are skills that are necessary for you to be able to implement AI with network.
Just going to throw some stuff into like Chat GPT and call it vibe networking and do that with CML. So
Please don't start.
vibe networking. I think we just coined a new term here.
So did we answer it? That's a triple high five.
Mine is the vibe coding.
The next question is, what is cloud computing and how does it work?
Let Quinn answer that.
I mean, so cloud networking it's the same stuff. I mean, we sound like a broken record, I think, at this point. It's the same stuff we've been talking about. The idea of layers and abstraction. So if we think about a traditional data center, we've gone from having a normal route switch, VLANs, IPs, all that kind of stuff. And then we've taken that a step level with either ACI or like a VXLAN EVPN fabric or something like that. So we've abstracted the transport underneath from what actually exists above it. I mean, cloud networking is the same thing. You create an abstraction so the provider has its network that connects all of these different servers and racks together in a certain way that's hidden from the user. And when we have the networking piece on top of that, it allows us to seamlessly connect disparate endpoints that may not need to be in the same rack, same row, same data center. And so when we've abstracted, we connect all those disparate endpoints together in this virtual private network or virtual private cloud. And then we can put, our normal cloud computing services on top of that. So whether we're doing like, virtual machines or whether we're doing functions or containers, whether we're running full-blown Kubernetes clusters on top of that, all of that is then kind of contained within that overlay network that we've created inside of the cloud. We can then connect that virtual private cloud to our on-prem data centers using some transport mechanism, whether it's a direct connect or we do some tunneling or whatever. And then we've got, a data center that can be available wherever we want and connect to whatever services we need. And the best part of it is we just pay for the management. We don't have to worry about the upgrades and the code and all the stuff from the infrastructure. We pay for that. That's why you pay for the cloud. You don't have to worry about any of that management piece. You worry about the end product you want to deliver, and the cloud provider handles the rest.
Couldn't have said it any better.
That's why I wanted him to answer, because I knew it would be better than anything you and I could give.
Yeah. I'm a little disappointed, and there was no duck analogy.
We're not done yet.
So as a network engineer, what should I focus on kind of in terms of Python?
Well, I actually have a new answer for that.
Ooh, I wanna hear it.
Don't worry about Python. I wouldn't say shy away from it necessarily. Maybe learn some a little bit, but I would say focus more on.
Don't say prompt engineering.
No. I would say focus more on like the more pervasive automation tools and what you need to do to build on those. So the ones that I'm going to talk about are Ansible and Terraform. You know, Ansible is based on YAML and has certain logic underlying it that I think is worth learning. Terraform has its own scripting language called, and correct me if I'm wrong, it's HCL, I believe. Can tell I haven't used Terraform in a while. And so I think those are probably your best use of time as a network engineer or even an infrastructure engineer. Where Python could come into play is when you've become comfortable in those scenarios and they're not solving your problems. But I would probably put to even the more expert engineers that you'd be a little hard pressed to find scenarios where you'd have to replace Python with those situations. But I think Quinn has one based on his little grimace there.
Yeah, it's ironic that we say that because I agree with you from an infrastructure automation space, Matt. I totally agree. Focus on infrastructure as code.
Okay.
I do a ton of presentations at Cisco Live around why we use these abstractions, because it simplifies a lot of the underlying processes that we need to do automation in terms of CI/CD and off-the-shelf tooling and all that kind of stuff. So I agree there. I think that it's over on this screen right here for a presentation I'm doing. I'm having to write a webhook listener to do custom parsing for, it's actually Splunk messages. So I'm having to take the webhook, parse it, do some actions on top of that, and that's all going to be running in a Flask app. So there are things from an automation standpoint that may not necessarily be infrastructure related.
That's a really good point.
That you need to learn the Python with. Now, I'm going to be calling Ansible playbook. So I parse the code, store that as a variable, and pass it into an Ansible playbook extended variable to do the actual provisioning of my routers and switches. But in order to build that framework, I've got to do it in Python.
Yeah, that's a good point. You can't build a listening service in Ansible. I agree.
I'll give a really short answer. If you really want to know what, from a Python library as a network engineer, what you'll be asked or what you might be using in the real world, go look at the DevNet Expert blueprint and libraries that are there. It's 95% of it is what you're likely going to be using in your automation through your automation journey in a real world. So that's, I don't necessarily agree with dumping Python or not starting with Python and do Ansible and HCL or Hashi, because I feel like the knowledge that you get from constructing the different automation pieces that you do manually in Python in order to connect somewhere, in order to authenticate, in order to push data or whatever, it's abstracted for us when we use tooling. And I think it's important to know these skills before you can jump into Ansible and HashiCorp and Terraform. So that's just my 2 cents. But I think short answer, if you really want to know what you're going to be using out there in production, go check out the DevNet Expert blueprint.
Well, I think to appropriately leverage those libraries, they'd have to understand the language to begin with. And so I don't necessarily want to change my argument too much, but I think you've convinced me that it's still worthwhile learning. I guess my point, what I'm trying to get across the point is that it doesn't need to be the primary focus at the beginning.
You're right. And I agree with that.
Okay.
And that leads super well to the next question, which is what kind of resources are available for these tools, whether it's Python or Ansible or Terraform?
There's plenty between our tutorials that we do on CiscoU. There's a set of automation related tutorials that you can just go out there and access today, all free resources. We have a couple of learning paths that are 100% free in CiscoU that are around automation for the network engineer. I think that's might be like a 25, 28 hour course that you can take, and it will get you everything that we talked about will get you there. I'm sure Matt, DevNet has a bunch too.
Yeah, on the DevNet side, it's more directed towards direct integrations with Cisco product, and we are migrating more towards the Ansible and Terraform content in support of that as well. They're a little more piecemeal, less learning path, learning journeys, but more designed for engineers that are comfortable with the space, but potentially need to learn a new Cisco platform.
So the next question is, how do you use Cisco APIs in automation?
Hate to give the IT answer, and I'm sure that Matt will correct me here, but it just depends. I mean, so it like the early days of DevNet, it was like, you know, using the APIs was glue, right? We had two platforms that didn't talk. And so you called some data out of one API, did some middleware, and then you pushed it to another API to connect those two disparate systems. So a lot of it is around either data abstraction, normalization, and trying to get some kind of unified picture, or it's to, you know, some kind of holistic orchestration routine where it's, I want to build some kind of data center fabric or an SD-WAN fabric or something. And so I'm going to use the APIs either directly through SDKs or something with like infrastructure as code with Ansible or Terraform to say, I want to build this and call these APIs to commit this code to there so it functions the way that I want.
Yeah, I think what we're seeing more and more from actually our product offerings are direct integrations that are already occurring. It doesn't preclude the need for APIs though. And so I would say there are probably two scenarios that I can think of off the top of my head. One where the direct integration doesn't exist and meets the auspices of Quinn's answer. The other one is just like bare bones situations where you're doing the same thing over and over again. I think that's where the first thing, as soon as I got to do it twice, I'm looking, is there an API for this and how can I automate that? That would be my advice is if people are evaluating it and they're going clicking the same box every 3 days, you know, can we run a cron job on that? Can we run a web application that does this? That would require Python, God damn it. Or is there an Ansible playbook or a Terraform provider that provides that opportunity for me to automate that? So that would be my thought on that. Spring, do you have a different answer?
No, I don't see any other use cases. It covers what you touched on, Matt, is like that same click ops that you do, you should automate it. There's should always be asking yourself, how can I do this better? That's where automation comes in play.
And this goes for security platforms, this goes for compute platforms, this goes for networking platforms, anything that Cisco sells. You know, there is likely some set of APIs for it. And there's always that opportunity built in that you can automate those processes.
Great. So my final question for today is, which technological innovation are you most excited about in 2025?
Ooh,
That's a good question.
okay, I have an answer. All right, so I feel I'm always like behind the curve. I feel like in technical innovation, like blockchain totally threw me for a loop, and I think it threw everyone for a loop because we were all trying to figure out how to use it not for crypto.
Mhm.
And there's opportunity, I still think, in it, but I think just as a more pop culture narrative, it's kind of phased out, right? And so I had the same kind of feeling about LLMs and Gen AI last year. I think that we're learning about the limitations a lot more quickly than we learned about the limitations of blockchain. And so I think that's given us an opportunity to be realistic about its application, and then potentially understanding the way to move forward. But the one that I'm really pumped about, and more so because I don't fully understand how it actually works, is quantum computing.
Yeah.
I very much believe that if, you know, the ubiquitous they actually solves our ability to leverage quantum computing in a cost-effective manner, that will revolutionize tech in the world in general. And so that's the one that I'm keeping a closer eye on, because I do really believe that it is the real game changer in the conversation.
You stole that from me, Matt.
I'm
That was
sorry.
my no, that was exactly. I'm excited about learning more about quantum computing, understanding it, even though it's super complex. Um, it's real. Like we talked about it. Like you go through university and you're like, oh, quantum computing and the concepts and
Theory and
quantum
entanglement.
physics and but like when you see it when you see it becoming real and it could impact what we do on a day-to-day basis, especially when it comes up the stack with AI and all of that, I think it's super, super exciting and it's super nerdy, which makes me even more excited about it. And so I have to second that, Matt.
Bring it to earth, Quinn.
Yeah, I have two. I'll go with one. I think that what I'm most encouraged about, and this is kind of I don't want to say it's the anti-AI bent, but
I'm in for it.
you know, with the concern around the concern around sustainability, you know, power, cooling, resources, all this stuff that's being dedicated to AI, and whether you know you're pro AI or not, there's still that environmental concern around that. I'm actually really interested in some of the advancements that are being made in the custom silicon architectures that are now powering a lot of different things. So, you know, whether it's, you know, ARM-based stuff, you know, the ultra low power things. It used to be you bought an ultra low power PC and it was good for one thing. You couldn't use it as a desktop computer. But being able to grasp these power gains and efficiency gains and rewriting architectures of code that you know, we're abandoning, you know, 40-year-old Intel architectures to now say we're going to be moving to ARM or other ULPC type stuff. That to me is incredible because it expands the reach of technology. Plus, it's also providing us general purpose compute that lowers that overall carbon footprint and sustainability and gets us lots more density, not having to worry about the, you know, the power and the cooling and all the other stuff that comes with that. So that's one. The other thing, it is kind of an AI related thing, but it's some of the scientific stuff around protein folding and genetic modifications and editing that's available through a lot of these SLMs that are being developed around sciencey level stuff. So it's like we can do these runs over and over and over again around proteins and how they can interact and
No.
discern, you know, new medications and new treatments and things like that because of those very finely tuned SLMs that are coming out of like Google and other places.
I love when Quinn is on this because he's way smarter than us, Cream, and
Well,
so
at least he just
I
sounds
knew
way
he'd have
smarter
a
than
more
us.
realistic answer.
Yeah.
I'm like quantum, and he's like, no, let's talk about things today. So thank you for bringing us back to Earth, Quinn. I really appreciate it. Emma, do we have anything else?
That is it. And as usual, if you, to the viewers who are watching this video, if you have a question that we didn't ask today, please drop it in the comments and we'll ask it next time.
Thank you, Quinn, for joining us this week. Emma, thank you for prompting us with all the great questions. Snackers, thank you for the great questions, and we'll see you guys next time.
Thank you all.